Hello everyone, this is Jitendra Chaubisa again with a new software for civil engineering, that is the ANSYS software. We are going to see how we can use the ANSYS software for the civil engineering purpose. Basically, it's a software that mechanical engineering students use, but there are many components of it that we can utilize in our civil engineering problems. So we are going to generally see in this PowerPoint presentation that how we are going to use this ANSYS software. Okay, so the first question that arises is, what is ANSYS software? What actually it does? Like we have the ETABS, StudPro, AutoCAD, and 3ds Max softwares. Same as that, we are having an ANSYS software. In actual, ANSYS is the name of the company, and it compromises of different type of components like the fluent component for fluid dynamics and the static structural component for the beam analysis. So this firm actually develops and market engineering simulation softwares for use across the product lifecycle. So it is generally making an simulation software. Simulation software means how a particular thing is going to behave when a specific kind of a stress comes onto it. So how it is going to behave, how the stresses will generate, how the deflection will take place. So all this simulation can be done here. Okay. So in the ANSYS mechanical finite element analysis, this is going to use the method of finite element analysis. That is, it is going to use the numerical differential equations to solve the deflections and the other parameters. So the finite element analysis software is used to simulate computer models of structure, electronics, or machine components for analyzing strength, toughness, elasticity, temperature distribution, electromagnetism, fluid flow, and many other attributes. So it can simulate many things like machine components like the belt drives and the rack and pinion arrangements. Then for civil purpose, it is having the um, bridge system, the truss element, and then the build beam analysis. So it can do a variety of things like the with the on depending on many other factors like the temperature distribution, elasticity. It can give the toughness and all the other things. Now, ANSYS is also used to determine how a product will function with different specifications without building test products or conducting crash tests. So it is quite useful that we don't need to build a practical model to get our tests done. The software can easily make the test done and can tell us how it is going to behave in the real life. So for example, ANSYS software may simulate how a bridge will hold up after years of traffic, or how to design a slide that uses less material without sacrificing safety. So there are quite different methods that we can use in the software. ANSYS offers a comprehensive software suite that spans the entire range of physics, providing access to virtually any field of engineering simulation that a design process require. So on and overall, we can say it's a simulation software that it is going to simulate different type of things, and we can easily predict with the help of this software that how that element or how that component is going to behave in real life when a specific kind of a stress, or you can say force, comes onto it. Okay, so this is all about, in short, it's a simulation software. Now, how we can use it in civil engineering? Okay, so what is its use in civil engineering that we are going to see. Now, the first point that is coming here is it can be used to analyze a specific building element such as a column or beam or a truss element to see how it will behave when a stress comes onto it. So uh, let's say we are having a column in our building, and it's the most critical column that we need to study. So we can make that model into the ANSYS, and we can apply those loadings onto over this, those moment, those forces and the pressure, and we can see how it is going to behave. We can see the stress distribution at each and every single level. So it is quite helpful in that case. Okay, it can also be used to analyze the behavior of structure under lateral loads like wind. We can use the fluent mode here, and we can see how that a building is going to behave when a particular wind with a particular speed is going to flow around it or flow over it. Okay, for designing of dampers in the building, ANSYS helps in determining the sizes of sections properties so that it works fine in the practical field. Everybody knows that we use the dampers and the base isolations for the earthquake resistant design building. So for that we also need the mechanical properties, like what will be the stiffness, what will be the toughness, and all these things, that they can be easily analyzed in this ANSYS software. Now it is a fluent solver. It has a fluent component which helps in doing all the fluid dynamics at one place. Okay, as a civil engineer, we need to learn the fluid dynamics and the hydraulics, because if we want to construct a you can say water treatment plant, then we need to know how much dia of pipe is needed, what kind of material of that pipe must have to be, what will be the pressure distribution, what will be the stress distribution, because that is going to depend on what material we are going to use. So with the fluent solver, we can build pipes, sewers, canals, and can see the discharge velocity, pressure, and the many more components distribution. Okay, we can see how much the velocity is going to get distributed, how much the discharge is going to be there. So okay, so it also has a static structural component which helps in analyzing all the types of beams, bars, ties, bolted connections to ensure a safety in the construction. So we can also construct the beams, the ties, the bolted and the welded connections also, and we can put the load onto it, and then we can see with the help of the finite element method that how the stresses are going to get uh, dispersed. Okay, now, so now I'm going to uh, show you that how the beam analysis is going to work. Then I'm also going to tell you the major application fields for the civil engineering. The first is the beam analysis. So the several types of beam, whether RC, that is reinforced concrete, or steel, can be analyzed in ANSYS in the most simplest way. Okay, so we can model any kind of a beam, like I beam, or if I want to model a channel section or an angle section, I can easily draw it, and I can also give it the support conditions. I can also give it the material properties, then the load is there, so all the things can be done at a single place. Okay, one can measure deflection stresses at any surface for an element. Several type of support conditions are offered in the software. Okay, you can see there are a bunch of images attached here in this PowerPoint presentation. You can see at under my cursor, it's an I section, and it is having a uniformly varying load of 0 at the one end and 4 megapascal at the other end. It is having a length of 0.5 meter. So how that deflections are going to be there, or you can say how the movement is going to be there, it can be shown in a very colored way. On the top left corner, I am having a simply supported beam with a uniformly distributed load onto over it. So how that thing is going to bend, what will be the maximum force at the upper surface and the lower surface, what will be the stresses, what will be the deflection in the center or above the neutral axis or below the neutral axis, we can easily get to know in the ANSYS software. Okay, so this is all about, that is beam analysis. Next is the urban simulation with ANSYS. Okay, urban simulation means if you are going to be an urban planner or a town planner, or if you are working with an organization which is going to plan a new you can say city out there, or they are going to plan a new row housing there, so you can easily see how the wind will flow over to that topography. Okay, because we have a bunch of buildings in it, so how that wind distribution is going to be there, we can easily calculate that thing in the urban simulation. So we can use the digital 3D simulation for urban planning process to analyze wind loads for the building, and then to improve the city ventilation. We can also perform CFD, that is the computational fluid dynamics analysis in ANSYS Fluent, to stimulate the wind flows around the building. Now with the simulations, we can easily improve the building's construction as well as safety and evacuation process. Okay, so there's a video here, and I have taken this video from the YouTube. You can see the how the urban simulation is going to work in this thing. I'm going to lower the sound a little bit, and then I'm going to start. You can see this is the model of a 3D town. Okay, and then these are the velocities that are going to be there. You can see after the initial buildings, the turbulence is getting generated in the behind buildings. Okay, and the values are also given on the left hand side. This is the pressure distribution of the wind, how this is going to be distributed. So in that way, we can see what are the critical areas where the pressure is going to be more and more. Okay, so all this colorful animations and all this colorful analysis can be done in the ANSYS by using the finite element method. Okay, so I have also attached here a couple of images regarding the other building components. On the next, we are having fluid dynamics. This is going to be very important. It's having a component of ANSYS Fluent. So fluid flow problems can be easily analyzed in that. We can model different type of pipes to study the laminar or the turbulent flow both. Okay. So flow over flat plates and the building structures can also be analyzed. You can see I have attached some images here of a bent pipe and a fluid injecting from a jet. Then we are having a car and the plane here. This is actually it is actually done to study the aerodynamics process. So it is not that much in the civil engineering, but for the pipes and all, we can easily use the ANSYS software. Okay, so this was the basic applications and it was the basic concept of the ANSYS software that an engineer must have to know. And for civil engineers, we are going to do in upcoming videos the analysis of simply supported beams, fixed beam, and then we are going to study the analysis of the columns and also the analysis of an bridge or a building component under the wind loads. Okay, I hope you understand the basic concept of it. If you have any question, please do drop your question in the comments below.